All right, guys, so we have our second example here. 5m minus p equals 7 and 7m minus b equals 11 are our system of equations. So if you answered that you were going to solve this by elimination, good job. And our biggest indicator is that our p's right here, everything's lined up. Obviously, 5 and 7 aren't going to be eliminated, but our p's right here are by themselves. They have the same coefficient, which means the same number in front of them. There's a 1 there that you can't see. The only problem is if I were to solve them vertically, I would get negative 2p, which is not correct. So what I have to do is multiply either the top or the bottom by negative so that one of those p's become positive. And the reason why we want to do that is so that we can get our p's to cancel out. So I'm going to go ahead. You know, I've said this in class a million times. I always like to multiply by a negative on the bottom equation. So I'm going to go ahead and multiply by negative 1 on the bottom. So now I'm going to have 5m minus p equals 7. And now it's going to become negative 7m plus p equals negative 11. Okay, so notice how now my p's, one's negative, one's positive. These are going to cancel out. And I'm going to do 5 minus 7. That becomes negative 2m is going to equal 7 minus 11, which is negative 4. I'm going to divide by negative 2 to get m by itself. And that is going to become a positive 2. So now that I know what m is, I can go ahead and plug that in to either the top or bottom equation. So I'm going to take a second. I'm picking the top equation because it's just not changed. You could also use the bottom equation as long as you use the original equation. So I'm going to have 5 times 2 minus p equals 7. I substituted this 2 right in for m in my top equation. So now that I can solve for p, I'm going to get 10 minus p equals 7. Minusing 10 on both sides to get that p by itself. I'm going to get negative p equals negative 3. So now if we were actually in class, I would ask, all right, can I leave it like that? And I'm hoping most of you would answer no, because we can't have a negative variable. We need that to be positive. So to get rid of that negative, you're going to divide by negative 1 on both sides. And you're going to be left with p equals 3. So we're going to write this as an ordered pair, and I've told you this in class as well, that when you go to write an ordered pair with different letters, so it may not be x, y, always go by the alphabet. So m comes before p, so I'm going to have 2, 3 as my solution for this problem.